Hello, in this episode, we're going to talk about simplifying rational functions. We know that rational function is made of, is a consequence of one polynomial divided by another polynomial. Okay, P is a polynomial and Q is a polynomial where the denominator cannot be zero. Being aware of, the denominator cannot be zero is important. And all the simplification we do is in the domain of the function, okay? And the process of simplifying often involve factoring and simplifying. Take the first example. Okay, suppose we have a rational function here, and this rational function is 4x squared divided by 2 times x raised to the power 3 minus 12x squared. Okay, so let's make the fonts just a little bit larger. And to simplify this expression, okay, and we would factor. The top is already in the factored form, so we just have to factor the denominator. In the denominator, we can factor out the 2, and we can factor out the x squared. And we will have a parentheses full of x, okay, minus 6. Okay, you can check by going backward. 2x squared times x is 2x raised to the power of 3. 2x squared times 6 is negative 12x squared. So this is a proper factor. And then all we have to do is just to reduce the x squares on top and bottom, and 4 and 2 reduce. So in the end, we get 2 times x minus 6. Okay, so this is an example of simplifying a rational function. Let's look at another example. Example number 2. Okay, we're still simplifying. Okay, and this function, we will have a 5 times x squared minus 10x divided by x squared minus 4x plus 4. Oops. The first thing we would do is that we factor the numerator. We can. Okay. In the numerator, we could factor out the 5 and we can factor out the x. So as a result, we're going to have an x minus 2. In the denominator, if we factor, we're going to get x minus 2 squared. And then simplify x minus 2. We have 1x minus 2 on the top, 1x minus 2 in the bottom. So the consequence will be x minus 2 under 5x. And there are no more common factors that can be factored out. Let's look at example number 3. Okay, so we're still simplifying. And in this, we're going to encounter a situation that we have a trinomial on top, and we also have a trinomial in the bottom. So once again, we're going to factor both the top and the bottom respectively. We cannot cross out the x squared yet. No, please don't do that. Okay. Please, no such steps. Okay. Please do not do the following. Okay. You cannot just cross out the x squares and x, you cannot do that. Okay, that's a no-no. Okay, now we're gonna factor these two. Okay, so it's gonna be x plus 1 on the top, squared on the bottom is x plus 3 times x plus 1. Factoring trinomials. So in the end, we will get x plus 1 in the denominator, take away x plus 1 of the x plus 1s on the top. So in the end, we have x plus 3 under x plus 1. And no more work to be done. Okay, do not cross out the x. Okay, do not cross out the x. Just leave it like that. Okay, so it's the same no. Please don't cross out the x. Okay, no. Please do not cross out the x's in here in this situation. Okay, that's a no-no. Okay, don't cross out these two. Okay, if you have any questions why we cannot, you should ask your teacher. Okay, so now, these are the examples of factoring. So let's do one more example. Let's do one more example. Okay, so I have one more example for you. Okay, so let's clean up all these drawings. And look at another example, example number 4. Okay, still simplifying. Oops. Simplify. Oh. Wait. Simplifying. Wait a second. What's wrong? Simplify. All right. The next example we're going to work with is I have an example here. We got x squared minus 1 over x squared minus a plus 5x minus 6. To simplify that, we will factor the top and bottom respectively. The denominator will be factored into x minus 1 times x plus 6. Okay, you can always check, right? This is a factoring trinomial. You can check your work, x squared 1x, 6x minus 6. Okay, and then x minus 1 will be simplified. So in the end, we have x plus 1 over x plus 6. Okay, so these are the examples of factoring trinomials. And there's some, let's do another example which involves a bit more factoring, And this one is example number 5. Still simplifying. Okay, we have a rational function like this. 2 times x squared plus 2x minus 12. Denominator, we have x raised to the power 3 plus 3x squared minus 4x minus 12. Okay, so the numerator it's a trinomial. The denominator has 4 terms. Okay, so we need to factor them respectively. On the top, we can first factor out the 2. Okay, 2 is out, and 2 is out, this becomes 6. So we have a parentheses like that. Okay, then you can continue to factor the inside. The denominator, we may try the grouping. We may try the grouping. So I'm going to group these two together. And these two, I'm going to factor out the negative sign. So I'm going to factor out this negative sign. So this will turn positive. Okay, be careful. You need to, because in these two terms, we factored out the negative sign. Next, we're going to factor 3 terms separately. Okay, so the top will become x plus 3 times x minus 2. That's a trinomial factoring. But the bottom, we can factor out the x squared. So the x squared is out. And we put the x squared over here. In these two, we can factor out the 4. So the 4 is out. And the 12 divided by 4 is a 3. Furthermore, between the two terms in the denominator, we can factor out the x plus 3. Like that. Okay. Furthermore, x squared minus 4 can be seen as x squared minus 2 squared. So we can factor this even further, which make x minus 2 times x plus 2. Now we can reduce. Okay, x minus 2 takes away the x minus 2. X plus 3 takes away the x plus 3. So in the end, we will be left with 2 over x plus 2. Okay, so x minus 2 is gone. So that's the final, we have a 2 over in the numerator. These are all the examples I think we can do today. If you need more examples, you can always find an intermediate algebra textbook to find such examples. And thank you for watching.